Graph the given quadratic equation. First, find the equation of the axis of symmetry and the vertex. Generate a table of values. Plot the points in the table and their symmetric points. Clearly label and scale the axes. Alright, so as suggested here, we're going to first find the equation of the axis of symmetry and the vertex, and we're given y equals x squared plus 4x minus 6. So then let's find the axis of symmetry. The axis of symmetry is given by x equals negative b over 2a, which is negative, and substituting for b, 2 substituting for a. And so simplifying that gives negative 4 over 2. Negative 4 over 2 is 2. So the axis of symmetry is x equals negative 2. So let's keep that in mind. Let's find the vertex. We have the x value for the vertex already, and it's negative 2. So let's find the y value. Y equals negative 2 squared plus 4 by negative 2 minus 6. And so that is 4 minus 8 minus 6, which is negative 4 minus 6 is negative 10. So then the vertex is negative 2, negative 10. Now, I know that the parabola is opening up. Because a is 1, right? The lead coefficient is 1, and that's greater than 0. So now I'm going to do a little table of values, and I already know an important value. And the vertex is negative 2, negative 10, and I have symmetry about that line. So in creating a little table of values here, I don't need to do as much work as I've done in the past. So for example, if I start with negative 2, I already know that the ordered pair is negative 2, negative 10. So now I'm just going to go in one direction from negative 2. Let's just go to negative 1. Alright, so then y would equal negative 1 squared plus 4 by negative 1 minus 6. And if we go through that arithmetic, that's 1 minus 4 minus 6. That's negative 9. And so we get negative 1, negative 9. Alright, what if we have 0? Then y would be 0 squared plus 4 times 0 minus 6. 0 plus 0 minus 6 is negative 6. And how about we let now x equal 1? And so we'd have 1 squared plus 4 by 1 minus 6. That's 1 plus 4, which is 5. 5 minus 6 is negative 1. So I have some points already. So let's see, this ordered pair is 1, negative 1. So I'm going to plot those points, and remember, the vertex is the lowest point on the curve in this case since the parabola is opening up. So I can use just a standard scale. Each mark means 1. Alright, and so I'll plot the points in blue. I have negative 2, negative 10. Negative 1, negative 9, 0, negative 6, and 1, negative 1. You might look at that and say, well, that doesn't look like a parabola. But remember, I have the axis of symmetry. So I have this axis of symmetry, which I'll draw with a dotted orange line here. And so since I have the symmetry about that line, I can use the symmetry to plot additional points at negative 3, negative 9, negative 4, negative 6, negative 5, negative 1. And in fact, if I continued Well, let's go another point to the right. Let's let x equal 2. If x equals 2, then y would equal 2 squared plus 4 by 2 minus 6, which is 4 plus 8 minus 6. That's 12 minus 6, which is 6. So I now have the point 2, 6 if I wanted an additional point. So I have 2, 1, 2, 3, 4, 5. There's 2, 6. By symmetry, I have also negative 6, 6. And so there's a bunch of points on the curve, and then we just want to draw our parabola shape. All right, so that's how we can use the symmetry of the curve to help us find additional points. All right, so here's another example. We have y equals negative 1/2 x squared plus 3x plus 8. Let's immediately note that the parabola opens down. Since a is negative, all right, let's find the equation of the axis of symmetry. So axis of symmetry would be given by x equals negative, substituting for b, over 2 times substituting for a. And so that's negative 3 over 1, negative 1, which is positive 3. So we have the axis of symmetry at x equals 3. Completing the vertex, y would equal negative 1/2 of 3 squared plus 3 times 3 plus 8. So that's negative 1/2 of 9 plus 9 plus 8. Let's work with decimals here. Negative 1/2 of 9 is negative 4.5 plus 9 plus 8, which is 4.5 plus 8, which is 12.5. So then the vertex is 3, 12.5. All right, and now we will substitute some additional x values, find corresponding y values, and use that and the symmetry of the curve. So I'm going to go ahead and use, now just sort of thinking ahead, notice that in this one, in finding the vertex, I had 3 as my x value. When I substituted for 3, I ended up with decimal numbers, and while it's not impossible to work with decimal numbers, I'd rather work with integers if at all possible. So what I'm going to do is use only even numbers when I substitute. So I'm going to substitute x equals 4, 6, 8, and how about 10? All right, and y is negative 1/2 of x squared plus 3x plus 8, and then we'll write some ordered pairs. All right, so if if x is 4, we'd have negative 1/2 of 4 squared plus 3 times 4 plus 8. So that's negative 1/2 of 16, that's negative 8, plus 12 plus 8, that's 12. So we have the ordered pair 4, 12. If x is 6, I have negative 1/2 of 6 squared plus 3 by 6 plus 8. So negative 1/2 of 36, that's negative 18, plus 18 plus 8. And so that's 8, so 6, 8. If x is 8, I have negative 1/2 of 8 squared plus 3 times 8 plus 8. So that's negative 1/2 of 64, that's negative 32, plus 24 plus 8, that's negative 8 plus 8, which is 0, so I have 8, 0. And if x is 10, I have negative 1/2 of 10 squared plus 3 times 10 plus 8, so that's negative 50 plus 30 plus 8. That's negative 20 plus 8 is negative 12. So I have 10, negative 12. All right, considering my x values and my y values and thinking of the symmetry here, I'm going to use a scale of 1 on the x's, and I'll use a scale of 2 on the y. So each mark is going to mean 2. So 2, 4, 6, 8, 10, 12, 14, 16. And similarly for the negatives. Oops. Negative 4, negative 6, negative 8, 12, 16. All right, let's plot what we know. The vertex is at negative 3, 12 point, I'm sorry, it's positive 3, 12.5. And messed up my scale there. 4, 8, this is 12, and this is 16. All right. Let's try this again. 3, 12.5 would be about here. And let's see, I have 4, 12, 8, 6, 8, 8, 0, 10, negative 12. Now, use the symmetry of the curve. All right, we have the symmetry about that line x equals 3, and plot some additional points. So I would also have 2, 12, 0, 8. Let's see. Negative 2, 0. And negative 4, negative 12. And there's the symmetry of the curve. And drawing it. All right, and so there's our parabola.